Alright, so today let's try to do Advent of Code in, it's basically Python, but I'm gonna use this weird brain-rotted version of Python called PyGyat, and I think it's gonna be funny. Since it's Python, should be a easy day, after all. I don't have syntax highlighting for Vim though, like it's gonna look white, and that's a bit sad, but it is what it is. Yeah, anyway, let's go through the 12th day of Advent of Code and see what it's about. So it's called garden groups, and we basically have a massive farm, and we make a stop here so the historian can eat something, and we see the puzzle input, and that's a map, and the map is gonna be basically a set of regions, and each region can grow only a single type of plant, and that plant is indicated by a letter. So for instance, we have this region, or I guess this map, and the region is plants that touch each other horizontally or vertically, so not on diagonals. That's a good one to think about. And this is a 4x4 arrangement, and it has only these kinds of plants, and they form these groups, right? So if you take a look, they form these groups, and it tells us the goal is to calculate the area in the perimeter, so we get the cost, and we need that to build the fence, right? We need the area and the perimeter, and obviously the area is pretty easy to calculate. It's just the number of regions, or I guess the number of garden plots in a region, and the perimeter is just how many sides this region has. And I guess if you don't know the formula, it's 2 times the number of plots plus 2, because you have, like, each plot is gonna have at least 2 sides, and the plots on the edges are gonna have 3 sides, so it's 2 times n plus 2. That's the formula for the perimeter, which I guess that would be where the entire difficulty of the problem comes from. If you don't know that, it's cooked, you know what I mean. Okay, and then we have another thing that says that plants can appear in multiple separate regions, so it's not mandatory that A needs to be next to another A. It can be all over the map, so that's another one. And here we have a much bigger example, right, with random letters and random regions. Maybe some of them are touching other. I think here it looks like all of them are in contact, but maybe we are gonna have a weirder input. We can check it out. It's, yeah, it looks like one of those, if you know what I mean, that grandma was doing, the not paintings, but yeah, where you have the pattern, you have to follow the pattern, right, and create like some kind of drawing with with threads, but I don't know how it's called. So this one has a total price, right, because we compute the area and the perimeter. So yeah, I would say it doesn't sound that complicated. We might be able to solve it, I guess, by just building a 2D map of the visited points, and then we just do breadth first search and fill in the visited points, and then keep like a not really a hash map, but a list of the perimeters and areas, or I guess the total straight up, because we know how to compute the total. So yeah, let's try to do that in PyGyat, I guess. So I've already installed it, and the way to install it is with pip. So just install PyGyat, and PyGyat is just, I guess it just converts code to Python or something like that. It's based on the Python with braces, but yeah, so you have to, I guess you don't have to name your file .gyat, but I think that makes it more fun. And I'm just gonna set the syntax to Python because I think this is gonna, I mean, yeah, LSP, but we won't be able to use the LSP if I think about it. Anyway, so yeah, let's try to figure out, I mean, we have the mapping between what each Python keyword or operator is and the PyGyat translation. But I think let's try to just figure it out by looking at the example.get file. So yeah, first let's try to get hello world going, right? So I mean, I guess I cheated a bit because I already know that chat is this real is if, and also syn yap, which probably means print, so we can yap hello world. That right, so you write that, and then you just run PyGyat on your file, and it runs the thing. Maybe something extra I have to do is to download the input, so let me just do that, and yeah. Right, so now that we have the input, we can, or I guess let's also have the TMP as usual, the temporary input, which is gonna be this big one. Right, so we can just easily run PyGyat and pass in TMP, but right now we are not doing anything with that. So I guess an important one is reading the input, right? But I'm not sure if I want to use input or just sysread. So let's import sys, right? Because I want to do sys. So to import stuff, we have to glaze. Yeah, we use glaze sys. So this is going to import sys. Yeah, I mean, obviously LSP doesn't work. What did I expect? Right. So let's let's try to read something. Sys.read. I guess this is a good test because I have no idea how to read stuff in Python. Sys Python 3 read all. Sys.stdin.read lines should give us all the lines. Right. So this is kind of the input. Yap input. So if we just print that, we get all the lines. Now obviously would be more useful to just read all, if that's possible. Let's see if read does that, or yeah, so we can read all the lines. So that's the input. Perfect. But you know, usually I like in Python to have that kind of if main, you know, if name is equal to main. So what we need for that is the if statement, and the if statement is chat is this real. So chat is this real, and then we have the condition, which is just name, and we need the equals, which is twin, and then main. So this should be how we define the main function. Perfect. Another one is defining the parse input function. Usually I have one of those, and I can see it's bop. So let's bop the parse input. So parse input is gonna take in an input, and it's gonna give us, not even sure, I guess a list of lines makes sense. So I was almost returning, but it's giving input dot trim, I guess. So I can open up, let me just move to this one so I can have all the dependencies if I install any. And we have trim, right? No, strip. So we strip the string and then split the lines, right? So we return that thing. So we can say garden is equal to parse input, and then we can print the garden. So my idea is that the garden should be a list of characters, kind of. That's the idea. Okay, so what's next is defining the part1 function, right? So let's define part1. Part1 takes in the garden and is gonna return a number. So how is this one? I'm just thinking, how can we use as many of these weird things as possible? So let's think. As I said, we need a visited map. So we need a visited with the same size as the garden. And that's one of the things we need, right? Because we need to, I mean, yeah, we need to just do BFS on the garden, and that's kind of it. So we can get the sizes of each plot. So yeah, let's just define visited. So visited is gonna be a list of lists, and is gonna be cooked for, oh, and even for has a different name. It's mewing. So let's mewing. Okay. We don't really care about this one because we just want to have a list multiple times. dd, I saw dd is in, and has is the range, so we might as well just say garden. Or I guess, does length have a, because len is a, oh, len is not on the list. I mean, that's a missed opportunity, but well, we can say width is equal to, I guess, even height is equal to len garden, and the height is gonna be len garden 0. So we create false for this, mewing dd has height. So we just create a cooked visited map, so everything is cooked in that visited array. So the goal is to get all of them some aura. Okay, perfect. So yeah, I guess BFS is the way to go with this one. So how should we call BFS actually? I'm thinking how we're gonna do that is basically go through all the positions again, right? So we are mewing IDD as width, but I guess height should be the first one, so we can call this one a row, and then newing column dd as width. So here we are gonna do something like chat is this real, chat is this visited, basically, of a row and column. So if this is visited, we edge. Okay, because we already visited that garden plot, right? That's the idea with this visited map. And if it's not visited, then we have to perform BFS on it. So I'm just gonna call BFS, and maybe we are gonna keep total is equal to 0, and BFS might just return that total, I'm thinking. But assign has a different name, I think. Oh no, it was just plus equals is fine. Oh, so I'm just gonna say is equal to total res BFS, because we can just use the plus. Nice. So we res BFS, and BFS is gonna take as an argument, I'm pretty sure it should take in the garden the visited map and then the row and the column, right? So we want to start the BFS search from the row column position and fill in visited as we go, right? So now I guess it's a good time to see how, and at the end, obviously, let's not forget to it's giving total. So just to make sure that I don't have any mistakes in this thing, let's just define BFS, and it does nothing for the beginning. So it's giving 0, and let's try to run it. I mean, I have to say yap part 1 plus str of part 1 in garden. Okay, part 1 is 0, perfect. And if I say, for instance, it's giving 1, then it's gonna be 100. Okay, so all seems to be working as expected. I guess the only thing that I have to do now is to just implement BFS. So how is BFS working? Well, we are having a queue, right? And this queue is going to contain a row and column. And the goal is to visit all the neighbors of the current cell, up, down, left, right. And if those are not visited and they are also in the same garden plot, so we can say plot is equal to garden of a row column. So we need to match this plot. Then we increase the total. So we are going to have a total is equal to 1 because we already have at least 1. But yeah, so that's how we are going to do this BFS. So let's mu. Or should we use a while loop just to have something different? While is what? Let him cook. I let him cook. Actually, yeah, while loop makes sense because it's let him cook while len q is greater than 0, sigma 0. Right. So while the queue is not empty, we have to pop from the queue. We have to pop from the front of the queue. So let's see, Python pop front. I mean, it's the C++, or how do I remove pop 0? Okay, so I'm gonna say a row and column. I can just omit that, is equal to q.pop0. So that's how we get the current point. I know the current point is actually this one, but bear with me, it's at some point it's going to be different, right? So the important thing is if this point is visited or the garden plot is not, maybe no, how I'm gonna do it actually is we are gonna make this one visited. So visited of row column is equal to aura, so it's true, and we have to visit all the adjacent nodes, right? So we are gonna have to do mewing direction. So I'm gonna say d directions. So directions is gonna be just a list directions, and we are gonna have 0 1 0 minus 1 1 0 and minus, like that. Nice. So now we can just add up. I mean, I can say d row and d column, right? And I don't think I need a parent. I don't remember. I think I need a parenthesis. So we can just say the neighbor row is a row is the column, and the neighbor column is column is, wait, the row. Okay, perfect. So chat, is this real? Chat, is this real? So when do we want to add the neighbor to the queue? Well, we want to add a neighbor to the queue if the visited is false and the garden plot is the same. So we are going to say if visited. Oh, do we have a keyword for not? Not really. So I'm going to say is false. If visited, okay, I like this one. If visited of neighbor row neighbor column is cooked and garden of neighbor row neighbor column a twin plot. So if it's not visited and the garden is the same kind of garden, then we are gonna say q dot append and row and column. So we just add this to the queue. Perfect. And we shouldn't forget about the total plus 1. And maybe that's better if I say total is equal to total raise 1 here. If I increase the total by 1 when we pop from the queue, maybe that's a better strategy. And this entire stuff is giving total. All right, so we format the entire thing nicely, like Python-like. And there we have BFS. Hopefully that change is visited. I think it does. So that's gonna, yeah, we make it through here. I think that's it. Hopefully it's not gonna just, list index is out of range. And yeah, it makes sense because we need to check that. You know what? The Python way of doing that is by doing a hack to here. So we hack to and that's like a try catch, right? Wait, where is try catch? I'm pretty sure that's what this hack to is here. No way. Speed on that. That's so stupid. So, I mean, we don't need a finally, but yeah, like the Python way of with exceptions, right? If it's out of range, then it's out of range. I mean, I can add here chat is this real if the row is less than 0, so if it's a beta or column is less than 0, then we can edge because it means that it's negative. And yeah, but if it's out of range, then we hack to that and we can say, okay, I don't really wait, pass, it's plu, so we plu that and plu here as well. 181, but that's for that's the number of but I don't even know what I counted here. Am I? It's funny because it should have been 100 if I think about it, but okay, maybe an oopsie doopsie. Wait, I'm curious, is the visited changing? Yep, visited. Yeah, it changes, but why is it 181? That's weird. Okay, let's yap here row column and garden of row column. So I'm curious to see, and maybe we can just yap here a new line, just have a difference. So you can see that all of them are the same garden plots. But we get the same 2, 4 here. There was another check I forgot about. It's shit. But how do you do that actually? So I have to set visited once we add to the queue. Okay. Okay, makes sense. So instead of doing it like that, let's do it the proper way. So visited. So once we add to the queue, we have to make it visited. Otherwise, we're gonna add trash to the queue. Right? We have to make it visited here. And then we add it to the queue. And then when we pop, we know we can res +1 And let's continue with yapping that. I'm just curious. So this should be 100, perfect, because it's only 100 elements. But instead of just +1, what we need to do is so this, maybe I can say num plots. So how many plots do we have? All right, how many plots do we have? And at the end we are gonna say it's giving total, or I guess we can have area is number of plots, and perimeter, or I guess let me just copy paste the word perimeter. As I said, it's gonna be using multiplication. Oh, we don't have multiplication. So it's gonna be 2 times, no, it's 2 plus 2 times number of plots, right? And this thing, we are gonna have the cost is area is perimeter. So that's the total cost. And if we run this, we get that one doesn't look very good. Huh. It looks kind of bad, I'll be honest with that. So let's try again to yap row column. Okay, because that's weird. Let's yap here. So we can see R's, and R is basically 12 of them times 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is multiplying the two. Oh, but you know what? I was wrong with that perimeter thingy. It's actually harder to get a perimeter, right? Shit. Well, but anyway, it was multiplication here. Yeah, it's actually because if one of these is in the center, then it has a contribution of 0 to the perimeter. That sucks. Because how are we gonna get the perimeter then? Like in the first example, it made sense, right? It's 2 times n plus 2, but for this one, it doesn't work because it's also squares. Here it was only lines. But even B, how did it work for B? I guess it was just lucky. Yeah, but in this case, it doesn't always work. Okay. So I guess we can just compute the perimeter while we do the BFS. Like that's the other option. So just have perimeter here as an argument, and basically based on the neighbors, like on the number of neighbors, we can do something. All right, so let's have here perimeter is 0, and I guess at this point we can just say area is 0 as well, but we already know that the number of plots is the area. So yeah, as I said here, I want to count the number of neighbors. So n count is 0. And if we add to the queue n count is equal to n count, there is 1. So that's how we get the number of neighbors. And the idea is that if you have, but that's not entirely true, because I need to know the neighbors that I don't care that they are cooked. I just want to know if they are the same plot. So let's do something like chat is this real, and we are gonna have two ifs. Chat is this real, and then let's move this if in, and now we can say there is one, so we can just reuse that if, right? So if it's the same plot, then we have one more neighbor with the same kind of plot, and if it's visited, then it's just cooked, we don't add it to the queue. And I guess the perimeter at the end is gonna be just, so after we finish mewing, we have to say perimeter, we add to the perimeter something, and what do we add? I think it's 4 minus the number of neighbors. So yeah, I think so, right? It's 4 minus number of neighbors. So we erase, and we need minus. We need 4 phantom tags and count. So that's how we get the perimeter. And then the cost is just, okay, let's see if that's actually the, ooh, sounds close. And it actually is. Who would have guessed? Input day 12. But is this actually gonna be enough to satisfy the, it actually was. Nice. So let's go to part 2 and let's see what it's about. Fortunately, the elves are trying to order so much fans that they qualify for a bulk discount. Okay, and if we have a bulk discount, instead of just using the perimeter, we need to use the number of sides each region has. So each straight section counts as a side. Bro, are we doing like, you know, the chunk algorithm of building meshes for like chunk-based games, right? So if it's a straight line, it's a side. So A has 4 sides basically, and that's what I'm thinking about. Makes me think about that algorithm of computing meshes for it's not tile based, it's like Minecraft. It has it's like a voxel map, right? And they compute this the mesh so that it's more efficient, right? And they use a specific algorithm for that. But anyways, let's see what's next. So each region, this one A has 4 sides. B also has 4 sides. C has 8 sides. Interesting. Using the new method, the per region price by multiplying the region's area by its number of sides. Wait, but it's funny because it's gonna be bigger. What? Oh no, it's actually smaller. This is kind of annoying. So here the E-shaped region has an area of 17 and 12 sides. Shit, how are we gonna actually solve this one? I guess we have to still do the perimeter, but let's think about it. So when does when do we have a side? Basically, if we have all the elements in the same row or in the same column, right? And each one has a perimeter of at least 0. That's kind of building a side. So if for instance these guys right here, they are on the same line, and I guess we can say that the minimum perimeter is 1, so in total they might have one side, all of them together. Or no, I mean yeah, it's weird. But I mean it has to something to do with the perimeter as well, like somehow reusing that information. Right. But how can we reuse that? Because I'm still thinking about doing BFS, obviously, to be able to get the area at least. But how about the number of sides? So it's 12 sides, it says, for this E shape. And then the X has this one has 4 sides, this one has 4 sides. So I could go through each character again, so through each plot, and have something like a map in which I'm gonna put. So let's say we take this one, right? And we know that in the up direction and the left direction, it's empty space. So we know that these can be points where sides begin. So I could say that, okay, on row 0, we have a upside, so a side to the north side, let's say. And then when we get to the second E, we say, okay, we already counted that side, so I'm not gonna count it again, but look down, we have a side down. Maybe something like that. It's a bit weird, but maybe it's gonna work. Let's see. So yeah, maybe we can just reuse this function. So let me just copy paste the BFS and part 1, and I'm gonna paste them here, and then I'm gonna say BFS2 and part 2. So maybe this one was BFS1. BFS1. Okay, and part 2 is just gonna be, let's see if it's gonna do the same. BFS2. but I mean, maybe we need that yap. For debugging purposes, but we get the same result, everything runs, so it's fine. Okay, so as I said, I think we are gonna need a sides and might be a hash map. So do we have something for the hash map? No, perfect. Oof. So we have a dict. And I guess I'm gonna remove the perimeter because that's not needed anymore. Okay, so the number of plots still needed. Okay. So all right, so for this row and column, we want to add a new side if it doesn't exist. So here, for instance, we have a row column coordinates, right? And okay, I'm not gonna do comments. I want to check if we have a side in the up direction, left, right, or down, right? I want to check basically the directions and see if we have a valid side there. But what's gonna be interesting is that for up and down sides, we only care about the row number because the column obviously is gonna be continuing. So that's what it is. And for the column, we only care about left and right edges, right? So then how is this thing gonna work? Is maybe it should be like two hash maps, one for the row sides and one for the column sides. Why not? So the row sides are gonna check up and down, and the column sides are gonna check left and right. Obviously, if we have less than 0, that's instantly like a side if we don't have one already. So I'm gonna say something like, chat, is this real? So if the neighbor row is less than 0, so that's the row, so it means up. It means that sides row of this row is equal to up, let's say, or shit. I mean, I could use default dict for this one just to be able to say, okay, it's up, and otherwise it's also down, but it's I guess it makes sense. Let's try to use default dict. So I have to say Python default dict. So it's from collections. So I have to say something like lock-in collections glaze default dict. Okay. So I want to declare it as a default dict because I don't want to deal with checking if it's empty or not. Right. So for this one we just append up, right? Because we said, okay, interesting. Maybe actually I need a set here so we don't have duplicates, and that's gonna be easier. So we just add up in this set, okay, because we have an empty slot at the top for this row. But it can be more complicated than that. It's kind of annoying because we can have like a bump in the middle, like imagine a fuck you symbol, and that has more sides. It's not only yeah, this one is interesting. I'm not sure. Yeah, imagine like finishing this and then debugging, and we actually find the fuck you symbol, and it's like, yeah, that makes sense. Okay, so maybe it's not using the default dict then. Maybe it's just walking around the perimeter, and while we have one of the rows or one of the columns yeah, I guess I could do something similar to this one, but like let's imagine we have a dictionary that has both row and column, and in this dictionary we keep up, down, left, right, depending on what kind of edge is next to this kind of right, and we build some kind of yeah, but how can we use this afterwards? That's my question, because sounds like a good idea, right? To do something like that, keep all the sides instead of computing the perimeter by doing +1 like we did here, right? We just keep the values of all the sides, but how can we actually use these sides? All right, so I could say it's gonna be I would say row column, right? Something like this. We add up, and then if if the column is less than 0, then we add left because it's a left side. Then here on the Tua case, we might have to do something like if n row is greater than do I have width? I think I had width. No. So it's len garden. Then we have a downside already. And if number column is greater than, let's say, one of the rows, then we have a right side. So perimeter is no longer a thing. I mean, we could just say perimeter is just gonna be the number of sides that we found. Oh wait, this is just sides. But we just want to find the continuous blocks. Right. So for instance here, if this is a twin block, then what am I saying? If this is like the same kind of garden plot, then we increase the count of the perimeter. But it also means that we don't have a empty space in that direction, so we don't have an edge there. We only have another plot. So it's only on the else case. But how do we write else? I think it's only in Ohio. Only in Ohio. We have to add another edge. But see, this one sucks. Maybe because here it's up, left, down, right. But here I need to map somehow the direction to like my thingy here, up, left, down, right. Which I mean should be just the value, so we can have something like map dir is gonna be a direction, and chat, is this real? Chat. Oh, do we have a switch? I mean, no, I don't really like switches in Python anyway, so chat, is this real? D twin directions 0. So this, it's giving kind of, so it's 0 1 row delta, so this is right. And then the last one, it's just giving some stuff. Then the second one seems to be left, this one is down, and this one is up. Right, so only in Ohio we say that sides of row and column, we add map dir, and here we have d row, d column, like this stuff. I guess. So if we yap the sides, I'm curious what the sides are going to be like for our TMP. 125. What did I write there? This sigma. sigma. So I'm thinking that these are gonna be the perimeter size, right? That's what I think. So for instance, S in the first example here, where is S? Oh no, really I just want to see where S is here. Oh, so it's here. So S has this one has 3 sides, right, left, and up. Nice. Then this one only has right and up, but it also has down. Why didn't it try that? What? Shouldn't it have gone here? Ah, it's sigma twin. It's sigma, it's greater or equal. Yeah. It's the Lulu. Damn, I need to use some goat. So it's sigma twin. Sigma twin. So now we should also see down and left, down, right, up. So how can we use these ones now? Okay, so let's see. Like it's can we use this information? That's the important part. Or how can we actually use this information to get the number of sides? So here we have row 8. It has side to the right, left, and up. We can only say for up though, if we are looking at the row. We can only say if it's something up. Right, and then we have to say, okay, let's move left or right. We don't really have anything to the left or to the right, so it means that okay, this edge is complete, or this side is complete, it's one side up. So then we move to I guess it might be something like, first let's check all the sides that are up, then left, right, and down. So we might say, okay, this one has a side up. Does it have any neighbors that it connects to? No, then we have one side. Then the next item that has a upside is this one. Does it have any neighbors? No. Maybe one that's more interesting is gonna be left. So it's like, okay, we have a left here. Does this one have any neighbors? Yeah, it does. It's one down below. So that one also counts as a continuation. Right. So maybe that's that would be more useful to have the reverse mapping. So sort of speak like which nodes have a opening to the left, an opening to the right, to up direction and down direction, or something like that. I mean, come on, it's gonna be like such a easy solution. I'm gonna look at someone else's solution. It's gonna be like 3 lines, and I already have 200 lines almost. Okay, so we have the sides. I feel like that's a good starting point, switching them around and then iterating each kind of side. So right, left, up, down. So let's try to do that. So I'm gonna say sides sides, how can we call them? Direction sides. These sides is gonna be like empty dictionary. Can be the default dict again. Why not? Default dict, and this time is gonna be just a list. That sounds like kind of a good idea in my opinion. So let's try it. So let's mewing. Let's mew the sides. So I want to mew the items, so key value. So we are mewing the position and edges, dd sides. So at this point we have to mew again the edges, and I'm gonna say these sides of edge append position. So basically I'm just reversing this dictionary, right? So these sides should be the other way around. Oops. For continue. Oh, for edge. Okay, yeah. So that confirms that the PyGyat actually just translates. It does just a regex probably. Wait, what? Wait. Wait, I'm not sure. So here it says that edges is an int. Oh, because I forgot items. Right, so see how it reversed it. So again, now if we take a look, okay, let's look at right. These two are connected, right? No, they are not. So these are two different edges, two different sides. Then for left, these two are connected because they have the same for here and also adjacent stuff. Then for up, it's also that they are connected, and down they are connected as well. Okay, but what if it's gonna be something weird, like, I don't know, a good example. Wow, all of these look like they are not connected, right? Or am I wrong? Because this one 8-3, 8-5, they are not next to each other. 5-2 doesn't have anything. 6-4 doesn't have anything. 7-5, 9-3, so they all look disconnected. But here there are two connected. 8-2 and 8-1. So I might want to sort them by row and then by column somehow, if that's possible. So let's see. So what I'm actually gonna do is mewing the edge and positions, or I guess just the edge in these sides. And what I'm gonna do is these sides e dot sort is that I mean it does something, but Python list sort, but I want to use my own comparator thingy. So reverse, I can use key, a function. So I can say key my tuple. So my tuple is going to be a function that sorts tuples. So let's bop my tuple key, my tuple sort. So it's gonna be a tuple, right? So we have x and y is equal to tup. And how does the key work? So it's just a number, right? So I might wait, but shit, I mean, I wanted to have a comparator function. Python sort with comparator function. From functools import this thing. So let's lock in glaze. So then we have two of them. So tuple 1, tuple 2. So this comparison is gonna be something like xdiff is gonna be tup 1 minus tup 2 of 0. Chat is this real xdiff 2 and 0, hopefully. So if this thing is 0, then we just it's giving to. I'm already going insane because of this trash language. Otherwise it's giving, yeah, I'm not gonna watch any more reels after this one. I think this is the cure actually to stop watching TikToks. Okay, so my tuple. So we just compare to key my tuple sort. Definitely this is the cure, I swear. Okay, so now they should be ordered by row, and if the rows are equal, they are ordered by column. So we should easily see now, for instance, here that these are connected. These two are on the same line, but they are not connected, so they form two different sides. These one are connected, so they form a side, and here is the same thing. It's these two are connected, but they are not connected with this one. So what that means is we can iterate all of them and check if they are connected. And I think that's it. I think we're close. I think we're close, chat. So how are we gonna do that? We have to say like perimeter is, and perimeter is gonna be the number of sides in this case. Yeah, why not? So let's start mewing. dd this is and let's take the points. Well, why not or like poses, pose items. Nice. So we get the thing. Okay, so we have to check now that they are connected. So I need the first item. So let's put this in hack2a. No, I found it funny. And if it fails, then we edge. Yeah, so we take position is gonna be pos 0. We take the first one, and we have to go through all the positions now. So we have to do a for loop. Mewing I dd. How do I make it? I need less tabs because it's. How do I do a range? We has already forgot about it. So we has from 1 to len of poses. I need help. I really need help. We have an auxiliary pose, and now we need an if statement. Chat, is this real? I swear. Well, actually, maybe it's a better idea to do each one individually. So like right, left, up, down, because the idea is for right edge kind, we just need to look at the column, or right, yeah, we need the same column, right? If they are not the same column, then we cannot do anything about it. So maybe even then we need to sort differently depending on what kind of thing we compare. Yeah, I think so. Shit. Okay, so sorting is gonna happen afterwards. Let's do something like this. So let's do first the sides of let's do right side first. Rights. So right pos. Rights. Why not the rights? We have rights. And here we can hack to again. Because I mean, I'm using this one just because it's funny, not because I would use that in real Python. I would never. That's insane. All right. So here we plu because we don't care about errors. So we take pause. But as I said, we need to sort it first because I deleted that. So we need to sort it first. We need to sort our rights, sort, compare my tuple sort, and we'll have X and Y. So here we sort by column. Where is the... So we'll have two sorts. One of them is going to sort by column and one of them is going to sort by row. And the one that sorts by column is just gonna be the reverse. Right, so it sorts like this. The sort by column. So yeah, that's what's gonna happen here. We are gonna sort by column, and then let's just edge here a little bit. Okay, so let's see. We take all the right sides and we sort by the column because we want the columns to be equal to be able to do something. Let me just actually let's yap rights and let's see if we actually have them correctly. I deleted the other yap. Let me just yap sides just so we see the sides and the sorted version. I mean, I wanted to see the rights before and after actually. That's a good point. Yeah. So you can see that here it's sorted by column, right? So now if we take the first one, we see that its column is different, so we just skip it entirely. These two have the same column number and they are also adjacent, so they form a line. This one with this one, same thing. No, because they have different columns, but this one with this one, the same thing. So that's how we are gonna do the right sides. Okay, so let's bring back the for loop. So here, chat, is this real? We care about the position 1 to be equal to poses, or I guess here it's rights I. So if these two things are equal, then we might be able to form an edge. We might be able to form an edge. So I have to say here and doesn't have a, okay, it doesn't. Jesus. And also position 0 is 1 is equal to, because they're gonna be like from low to high, so it's gonna be +1, rights I 0, here it's rights I1. So if these two things are equal, then we keep going with the same edge, right? We don't do anything basically. Maybe what I'm gonna do here is perimeter is equal to perimeter raise 1, but it means that here we just say position is equal to rights I, but that should happen every time. So maybe on the else case, we can say that we just increase the perimeter by 1. Let's think. So for this stuff, how are we gonna do the perimeter? So we have this guy, it's not equal, so we say perimeter is 1, or the number of edges. Then we go next and compare with this one. These two have the same number, they are also in the same order, so we just go next, we don't increase the perimeter. We compare this one with this one, they have different coordinates, so we have perimeter is equal to 2, and we are on this one. This one is different than this one, so perimeter is becoming 3. We have 3 sides. This one is equal to this one, they are also in the same order, so we go next, but we reached the end. So I said this one, perimeter becomes 1, so we add extra 1 at the end, I guess. I guess this could be at the end to signify that. Okay, so here, I guess if not pause, oh, I guess we have a different word for not equals, right? No, we don't. So not or not this one, we just increase the perimeter by 1. So can I yap perimeter? And can I also yap again the rights and after we sort? So here you can see we have 4 sides. This is one of them, this is another one, this is another one, and this is the last one. Here we have 2 sides as well, and here we have 2 sides as well. Nice. So it looks like it's working. Hopefully it's working, because otherwise it's gonna be really bad. Oof, it's gonna suck. Okay, so this was just the right side. Let's do left sides, which if you don't believe me, it's the same thing. Okay, because right sides and left sides is the same. Is it the same thing though? Yeah, it's just a different array, but it's the same thing. Then upsides, you guessed it, we just have to switch this to be a row sort, and then we need the rows to be equal and the columns to be sorted like this. The rest is the same, and maybe just something like that. And then the downsides, we are gonna switch this to down. Same sort, same stuff, same stuff. So is this gonna work? Actually, it didn't. Actually, it did not work. Yep, perimeter. So S has, I guess it has 6 sides. M has 6 sides, nice. I missed a side for I, shit. E has 8 sides, nice. C has 4 sides. I missed another one there, interesting. I wonder how did I miss it. Maybe an off by 1 error. J has again off by 1. 9, 11, 17. Whoops. For C we have a bigger difference than I and R. So they are close, but I clearly missed something. So what did I miss? Let's yap the rights. I guess I'm gonna yap the sorted ones because okay, so these are the, so for S's, which S was correct, so let's not look at this, let's look at C, which C, I think it has only one thingy. Wait, where is the, so C has I mean C appears multiple times, so where is the C? At 4, 7, at 4, 7. So 4, 7 would mean row 4, 0, 1, 2, 3, 4, line 7. So this guy. So why did it say, I mean 4, 7 is fine, 4, 7, 4, 7, 4, 7, but for the down ones, it didn't count it. So we don't have anything in the right for the downside. And row, so this one is not it because it's in bounds. So is this, I mean, I don't get it. Did I just not put... Oh. Yeah. My bad. It was not the right index in the thingy. So now it's the real question. Is it gonna... Wait, did it just work? It just... No way, that's no cap. If if this thing doesn't work, I'm just uninstalling PyGyat. Okay. I was about to uninstall PyGyat. I'm glad I didn't. I'm glad we went with the struggle of this trash. It's... Yeah, I mean, we actually got it. We actually got both parts in PyGyat. It was horrible. Like, you wouldn't even... Let me just remove all the yaps because they are annoying. So we have a bunch of yaps. Okay, so now it's just the output. Perfect. I mean, I'm curious what the actual solution looked like, because this one is clearly shouldn't see the light of day, but it is what it is. I mean, at the end of the day, if it works, right? So yeah, that's yeah, I mean, no comments, to be honest. It's just that I'm gonna pip3 uninstall this trash. I'm just kidding, but yeah, that's the vibe I'm getting. Wasn't really able to use all of these things. I mean, some of them I don't even, like non-local, I don't even know what it does in Python, so that's yeah, like creating a skibidi. Sure, I mean, we could have done a bunch more things, like even using nuns. But I think I'm curious if it's actually gonna, like, I know there is a VS Code syntax extension. I'm curious if it's... maybe not. I mean, I'm sure in GitHub it's not gonna work, but I was curious if it shows the highlight there, but I don't think so. Yeah, I mean, that's kind of it. It's we like yeah, it's just how I said in the beginning. I think this is a cure to no longer want to watch any reels for at least a month. Yeah, I mean, yeah, it's disgusting. It's really like it's the pinnacle of Brainrot. So what can I say? I mean, so we actually got both parts in Python, let's say, PyGyat. I mean, I'm gonna use normal Python at some point, and we'll see the difference. Like, it's gonna be a bit easier because we don't have to think about writing each keyword. And I think there was also another language that I was thinking about that was interesting, but I forgot it. I think it was also like a C-like kind of language. I'll have to think about it, but yeah, maybe I'll remember it. Yeah, anyway, like this was day 12. Pretty interesting. I mean, I guess Python was a good choice for it, honestly, like because it was kind of long. Maybe I just went on a tangent and found a harder solution. Maybe there was an easier one, as I thought in the beginning that you just use a formula for the perimeter, but that formula was wrong. But maybe it actually is a formula for it, and I just didn't get it. And maybe it's the same thing for the number of sites. Maybe there was a formula, but if I never solve the problem that uses that formula, then there's no way I can figure it out in 1 hour. So yeah, hopefully this was interesting. I mean, kind of brain-rotted, but hopefully you got the main idea of how to solve day 12. And yeah, you know, the rest was more like entertaining purposes, the PyGyat thingy. So yeah, hopefully you enjoyed this one, and we'll see next time. So see you.